Okay, can see the PowerPoint?
Yes, yes.
Okay, thanks. Yes, everyone is here. Oh, only for a few, eh? Okay, so let's restart. Okay, so that day we discussed about AM, FM, why there is a need for modulation. Okay, why you need to modulate the signal? Because so that many conversation can be can involve in the same place simultaneously without any interference. Okay, that's why we need modulation. Okay, AM modulation, FM modulation. Okay, AM modulation, the displacement of the what do you call the amplitude is varied in synchrony with the displacement of the information signal. Okay, AM modulation. AM modulation have sidebands. You have the sidebands. Okay, sidebands. The width of the sideband is called bandwidth. The range of frequency where the signal is occupies. Okay, the half of the bandwidth is the maximum frequency signal it carries. Okay, greater the bandwidth. If the bandwidth get big, what's the problem you're going to face? You will have less radio stations in a particular waveband. Okay, but benefit is you can carry more information. Okay, instead of sound, you can now carry video. Okay, normally high frequency carriers will have a greater bandwidth because not much what do you call occupied by other users. Okay, like satellite like satellite communication, they occupy a very high frequency gigahertz, which nobody really occupied. People starting to explore. So they can have a big bandwidth. Okay, carry lots of information. Okay. So that day I told you to draw this graph. Okay, when you draw this graph, remember the pattern of the graph of AM should be like this. Should be like this. Okay, should be like this. Remember, you can start draw from maybe from the bottom here. You can start draw from here to here. This called one period. Okay, it's one period. Don't treat this as half sine. This is a complete sine graph. It's a complete sine graph or complete a cos graph. Sorry, cos graph from here to here, like a one cos graph, one cross graph, so one period. Okay, you have a shorter period. This shorter period. Okay, the longer. This is the T1. This is T2. T1 goes for period of the signal. Goes for the period of the signal. T2 goes for the period of the what do you call of the carrier. Okay, T2 is the period of the carrier, a small carrier. So remember, when you draw the AM signal, you have to draw this pattern. You have to draw this pattern. Okay, this pattern. That means from smaller getting bigger, then getting smaller back. But when you draw, you must be careful with the period. This small period is of the carrier. Okay, let's say carrier frequency given 700 megahertz. So you find the period of that carrier. Let's say you got 2 milliseconds, and then this width, the small width, should be 2 milliseconds. Okay, the what do you call the trough to trough? Okay, like going up and come down. The pattern is like a trough to trough. This is going to be the period of the signal. The signal they might give like 500 kilohertz. Okay, so you do 1 hour frequency, get that period. That period is going to be the longest one. Okay, so that's how you draw this graph. Okay, where's the graph? This graph. Okay, so here we found that the carrier is only 20 microsecond, and the signal period is 200 microseconds. So how do you draw? So the pattern should be from here, should go up. 200 is where? So you start from 200 is where? 200 is here, 200 from here to here. The pattern should go up. Where's the middle? Middle is 100. Okay, 100 is somewhere here. So the pattern should go up like this and come down like this. Okay, same thing happens here. Okay, same thing happens here. Okay, so then what do? You draw the pattern. It's like this. It's like this. Okay, class, just sorry. Just give me a 5 minutes. Let me get my son first. Okay, just take a 3 minutes break. Then I get back to you. Sorry, just 3 minutes.